Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
A research team at the Cluster of Excellence Physics of Life of TU Dresden and the University of California, Santa Barbara, reveals how cells sense their mechanical environment as they build tissues during embryogenesis. Building tissues and organs is one of the most complex and essential tasks that cells must accomplish during embryogenesis. In this collective task, cells communicate through a variety of communication methods, including biochemical signals, similar to a cell's sense of smell, and mechanical cues, the cell's sense of touch. Researchers in a variety of disciplines have been fascinated by cell communication for decades. Their paper has now been published in the journal Nature Materials. Testing the surroundings in their paper, the researchers report how cells within a living embryo mechanically test their environment and what mechanical parameters and structures they perceive. Previous works revealed that stem cells placed on a synthetic substrate rely heavily on mechanical cues to make decisions. Cells on surfaces with a stiffness similar to bones became osteoblasts, bone cells, whereas cells on surfaces with a stiffness similar to brain tissue became neurons. The findings greatly advanced the field of tissue engineering as researchers used these mechanical cues to create synthetic scaffolds to coax stem cells to develop into desired outcomes. These scaffolds are used today in a variety of biomedical applications. From a dish to the living embryo, however, a dish is not the cell's natural habitat. While building an organism, cells are not in contact with synthetic scaffolds in a flat dish, but rather with complex living materials in 3 dimensions. Over the last decade, Professor Campàs' research group uncovered the mechanical cues that guide cells in the complex tissues of an embryo. Using a unique technique developed in his lab, the researchers could probe the living tissue in a similar way as cells do and find out what mechanical structures the cells sense. We first studied how cells mechanically test their microenvironment as they differentiate and build the body axis of a vertebrate. As they differentiate, Campàs said, cells used different protrusions to push and pull on their environment. Sensing the tissue architecture and cells change fate critical to these embryonic cells' actions as their collective physical state, which Campàs and his research group described in a previous paper to be that of an active foam, similar in consistency to soap suds or beer froth, with cells clumped T. What the cells are mechanically probing, Campàs and team found out, is the collective state of this living foam, how stiff it is and how confined the assemblage is. And right at the moment that cells differentiate and decide to change their fate, there is a change in the material properties of the tissue that they perceive. According to him, at the moment the cells within the tissue decide on their fate, the tissue falls its stiffness. Going forward, what's not yet proven in this study is the complex question of whether, and if so, how, the change in the stiffness in the embryonic environment drives the change in the cell state. Nature Materials, 2022, doi 10.1038, S41563, 022, 01433, 9 Technische Universität Dresden. A glimpse of a cell's sense of touch. Science Daily, the 28th of December 2022. ift.tt/mpk80lz. A glimpse of a cell's sense of touch. Science Daily. ift.tt/mpk80lz. Access December 28, 2022. Thanks for watching. Please subscribe my channel for more videos.